Hi, so in this video we're going to rewrite the parser that we did before so it calculates the arithmetic expression while we parse. Let's see. So first we don't need this anymore. Also we don't need the ident level. Scan, we can remove this statement. We still keep this. In main we still do scan and we still do exp as before. And then in exp, what we'll do instead is we'll remove this one, and then we'll say that res is the result of term, and also that res is the result of invoking x prime with res as the argument. So res is an arithmetic expression that will be obtained by recursively traversing term. We can remove the last bit here as well and simply return res instead. So that was it for exp. So maybe we should also do something. Yeah, we can do a print. So we do print ln, and then we do result of res is $res, like this. And then for term we remove this, and we should also remove this. And of course factor is either an identifier or a constant, so we'll do this. And then we get term prime, and for term prime what are we going to do? For term prime the result should be yes, so we should do res equals to term prime, and then we should pass in res. And let's see, and then we should remove this and simply return res here. So that is it for term prime. Then we go to x prime. We have an ident level, we don't need that. Neither do we need that one. And this we can ignore. Print an ident, of course, we can remove. So instead we will invoke scan, and then we'll say res is equal to res plus term. Let's see, and then we call we can remove this call because we'll get it from here instead, and then we'll call x prime with res, so we will return this. And for the current token is minus, we will simply do the exact same thing. So let's remove those 3 lines here and copy these 3 lines. So something like this, but this should be a minus of course and not plus. And here for epsilon we simply return res, we do nothing. And res of course here is being passed a parameter. You can see on line 43. Then we don't need to do anything about the ident level anymore. For term prime we will do the same, so we'll pass res. We don't need any idention, so we'll remove that. We'll call scan. We'll do this. And for factor, yeah, we will simply do yes, what should this be then? Yeah, that should simply be res, and then we should have res times whatever factor returns, and then after we've done that we should return the result of x prime. And these 3 things here should be the same. Like so. Thinking about it now, this should be, we are in term prime of course, so this should not be x prime, it should be term prime actually. And the same goes with this one. You can see the grammar up here. Let's do a highlight. Oh, I should maybe copy and then do Yeah, didn't go so well. See up here. And then for epsilon, yes, let's simply return the result. We can remove this. And this, of course, should not be times, it should be division. And then we go to factor down here. And for factor, we are gonna check if we have an open parenthesis as before. But let's not write to res, let's instead do this. And then we should call exp, whatever we have in exp here. And then we should make sure that we have, so exp should be a result. It will return one, or rather it will print one. So we might have an issue here. It prints the result of res up here. So maybe we should instead say that res is equal to exp here. And then move this print up here. So we instead get this. So now we should do this, and as long as we get a closing parenthesis, we should simply return res here. And now we have the regex stuff here. So what we'll do here instead is that we will, let's see, and of course scan should not be assigned here. So what we'll do here instead is that we will say that res is equal to, the result of invoking parse. So in Julia you can call the parser as a part of a running program, so it will, for instance, if we get a float, or if we can interpret it as a float, we will get a float back. So for numbers we parse them directly, and to this we pass the current token, like so. And of course we shouldn't do this, but very well we should scan, and then we should return res here. And then we have an else if nothing, and of course we don't support identifiers yet. So in this video we'll not add support for identifiers. Otherwise, maybe we should have some kind of scheme where you can submit identifiers and do something with them. But nevertheless, I am going to write something here. So, oh yes, this was of course for the identifiers. Sorry, for the numbers, not for this is for the numbers, so this code should really be here when I think about it. And then we can simply remove these three things and do it like this. And of course up here we can for now we can simply throw an error. I leave it as an exercise, of course, if somebody wants to fix it or implement it themselves. To do not implemented. Smiley face, something like this. And then we have res, otherwise we throw unexpected token. Let's remove this as well. Yeah, so this looks alright. So otherwise we just throw, and we will call main as before here. Let's remove this redundant line. Save our file. So these are our program. So we have term prime, x prime. Yes, this looks alright. So now let's switch to a terminal and see where we end up. So let's try it out and see where we end up. 1 plus 1 plus 1. Okay, undef var ident level is not defined, so I made a mistake. So let's correct that. So I made a mistake. I had not removed the ident level from this last method here. So I removed these two lines. See if we see another mistake. Yes, here println is misspelled, of course, so let's correct that. So now we are in PowerShell. Let's see if we can fix it so that it runs. 1 plus 1 plus 1, that is 3. Looks good. 1 times 2 plus 3. This should be 5. It is 5. 1 divided by 1 should be 1. It's 1. 1 minus 1 should be 0. That is 0. 9 times 9 times 9. Sorry, 9 times 9. That is 81. Then takes that times 2. That should be 162, I think. Yes, it's 162. And just like 5 times 5 times 5, 125. Yeah, it looks alright. So we did it. And if you do it like this, you write the grammar and you remove direct left recursion. Sometimes you might need to remove all left recursion. Then you can make a simple top-down parser to evaluate, for instance, arithmetic expressions following a simple scheme.